All right, so additional topic number 2 is on radical equations. So this should kind of be review for you. We've done this with fractional exponents before, like raising things to the 1/2, so that we square both sides. It's the exact same concept. All right, so if I have the square root of 2x plus 1 equals x, I need to isolate your absolute value, or isolate, not absolute value. So isolate your root. Similar to absolute value problems that we've done before. Okay, so that means I need to take this plus 1 and I need to subtract it over. So I'm going to have minus 1. So x minus 1. Then I have 2x plus 1 under a root. I get rid of my square root by squaring both sides. So you're going to get 2x plus 1 on the left side. And then hopefully you guys are at the point where you no longer call this x squared minus 1, right? What do we have to do? You have to FOIL, right? So you write it as x minus 1 times x minus 1. So you get x squared. Your outer is negative 1x, your inner is negative 1x, and your last is plus 1. So you get x squared minus 2x plus 1. And if you notice, we have x squared terms and we have x terms. We can't get rid of our x squared terms. Sometimes you'll have like an x squared on both sides, and so they'll go away. But in this case, we can't get rid of the x squared, so we have to get everything on one side. Okay, so I'm going to subtract my 2x over. And then I'm going to subtract the 1 over as well. So I'm going to have 0 equals x squared minus 4x, and then the plus 1 and minus 1 cancel. So if 0 equals x squared minus 4x, they have a common factor. So you can pull out the x that they have in common. So you have x minus 4 left. So you have two things multiplying to be 0. So that means either x could be 0 or x minus 4 could be 0. So x equals 0 or x equals 4. Those are your solutions. Since you have a square root in your original, what could possibly happen that would make these answers wrong? So what could happen? What can we not have under the square root?
A negative?
Yeah, we can't have negatives under the square root. So if you have the square root of a negative, then your answer is not going to be correct. So you should always go back and quickly check these answers. So if I check 0, and I plug it into my original, I'm going to have the square root of 2 times 0 plus 1, and I want to see if it equals 0. In this case, you get 1 plus 1 equals 0. Does that work? No, it does not. So 0 is out. So 0 actually did not work as a solution. We also want to check x equals 4. So when I check x equals 4, I have the square root of 2 times 4 plus 1, and I'm seeing if that's equal to 4. So I get the square root of 9, which is 3, plus 1. Yes, that does equal 4. So 4 is the only solution that works. All right, so let's try the next one. So we need to isolate our radical. So let's subtract our x over. This is a little bit harder. So I'm going to have negative square root of x plus 3 equals x over 2 minus x. Now I can actually combine those. X over 2 minus x. You can think of getting common denominators, like 2 over 2. So you'd have x minus 2x all over 2. So it's negative x over 2. Does that make sense? You could also think of 1/2 x minus 1x is negative 1/2 x, right? So it's negative x over 2 when you combine them equals negative square root of x plus 3. We'll go ahead and divide by a negative. You don't need to because you could go ahead and square both sides and the negatives would go away anyway, but let's divide by our negative anyway. So square root of x plus 3 equals x over 2. And we're ready to square. So we square to get rid of our square root. So on the left, I just get x plus 3, so whatever was under the root before. On the right, I need to square the top and square the bottom. Right? It's x over 2 times x over 2. So when I square the top, it's x squared. When I square the bottom, you get 4. Is it bothering you that you have a fraction? If it bothers you, you can clear the fractions. So what could I multiply through by to get rid of my fraction? 4. So let's clear the fraction. I'm going to multiply by 4 on both sides. So when I do, I get 4x plus 12 equals x squared. I have x squared terms and I have x terms. So if you remember, whenever that happens, we get them all on one side and we factor. So I get x squared minus 4x minus 12 equals 0. I always get them on the side where I have positive x squared. I don't like to have a negative x squared because it's harder to factor that way. All right, and I'm going to try to factor. So my first spots need to multiply to be x squared, so I need x and x. My last spots need to multiply to be negative 12. So you could have 1 and 12, 2 and 6, 3 and 4. And they need to be opposite signs because they need to multiply to be a negative. And then your outer and inner need to combine to be negative 4. Okay, so if you put 6 and 2 in, and you make it negative 6 and positive 2. See how your outer is negative 6x and your inner is positive 2x? That's how you get negative 4x. Okay, so that's what we need. So negative 6 and positive 2. They're both set equal to 0, right? So you have two things multiplied together that make 0, so one of them has to be 0. So I get x equals negative 2 and x equals 6. Okay, quickly check your answers. See, these are a little bit long, but it's a pretty easy process. So when you check, you would have negative 2 minus the square root of negative 2 plus 3. You're seeing if it's equal to negative 2 over 2. So you have negative 2 minus 1 equals negative 1. Is that true? No. Right, negative 3 is not equal to negative 1. So that one's out. So negative 2's out. So we try 6. So when I try 6, I'm going to have 6 minus the square root of 6 plus 3, so I'm just plugging in the original, equals 6 over 2. So I get 6 minus 3 equals 3. True? Yep. So 6 is the answer. Okay, does this make sense? All right, the next one looks scary. It's not scary. It's not bad. You're just going to have to square twice. So go ahead and try this one. So try 3. I'll come around and help. Okay. So you guys have big numbers, but I think it's working out for all of you guys. So you're going to first square to get rid of that outside square root. So when you do that, you have the square root of x plus 5 plus x equals 25. Okay, and you can't just square right now, because if you squared right now, you would have the square root of x plus 5 plus x times itself. That's what squaring means. And then you'd still have your outer and inner terms. So you'd still have a square root. So we can't square until we isolate the square root. Okay, so we have to subtract the x over. So 25 minus x, and then square root of x plus 5. Okay, now you can square. So now square both sides. So when you do that, you get x plus 5 equals, we're going to write it as 25 minus x times 25 minus x, because we know we have to FOIL. We know we can't just bring the square in. So 25 times 25 is 625. Your outer is negative 25x. Your inner is negative 25x. Your last is plus x squared. So many of you guys got to this point. I saw it. So you should have 625 minus 50x plus x squared equals x plus 5. Okay, we have x squared terms and we have x terms, so we need to get them on one side and factor. So I'm going to have my x squared. I'm going to subtract my x over to be with the other x's, so I get negative 51x. Then I'm going to subtract my 5 over, so I get plus 620 equals 0. Okay, now here's kind of the hard part. You need to think about factors of 620. Did you get them, Karen? Yep. So I noticed it was divisible by 20. And I was like, 20 times what? 20 times 31. And I was like, oh, those work. Okay, so you kind of have to think about some different things. I mean, it's easiest to think about tens when they're that big. Like 10, 20, 30. Okay, so here I'd get x minus 20 times x minus 31. So that means x minus 20 could be 0, or x minus 31 could be 0. So x could equal 20, or x could equal 31. And we should check. So when I check, I'm going to do my big square root, my little square root. So I have 20 plus 5 under the root, plus 20. I want to see if that equals 5. So under this first little square root, right, you kind of have to work from the inside out, kind of like inner parentheses. Okay, so from this inside square root, I have square root of 25, which is 5. So I'm going to get the square root of 5 plus 20 is 5. So it works. That's a question mark. All right, so I know 20 works. Try 31. So if I check 31, I have the square root of 31 plus 5 plus 31. I want to see if it's equal to 5. So if I start on the inner part, square root of 31 plus 5 is square root of 36, which is 6. So I have 6 plus 31 under square root. So square root of 37. Is that equal to 5? No. So once you see it's not equal, just cross it out. So 20 is the only answer. You could have more than one answer. All right, number 4. So we need to isolate, so I need to subtract the 1. So I'm going to have the square root of 5 minus x equals x minus 3. So I've isolated my root, so now I can square. So I get 5 minus x equals, I need to write it as x minus 3 times x minus 3. So I get x squared. My outer is negative 3x. My inner is negative 3x. My last is plus 9, right? You guys all remember that, right? I have 5 minus x. Combine your like terms, I get x squared minus 6x plus 9. And I still have my 5 minus x. I want to get everything on one side, so I'm going to add x over. Plus x, plus x. I'm also going to subtract 5. So I'm going to get 0 equals x squared minus 5x plus 4. Okay, think about how it factors. The last numbers need to multiply to be positive 4. So that means they need to be the same sign to multiply to be a positive. They both have to be negative. Do you guys see why they both have to be negative? Because the middle term's negative, right? So I need 2 negatives. Numbers that multiply to be 4, I could have 2 and 2, 4 and 1. 4 and 1 is what's going to combine to give the outer and inner. So when you add the outer and inner, you get negative 4x and negative 1x. Those add to be negative 5x. So I get x equals 1 and x equals 4. Right, you can say x minus 1 equals 0, x minus 4 equals 0. All right, so then I check. So if I check in the original, I have the square root of 5 minus 1 plus 1. I'm seeing if it's equal to 1 minus 2. I can already tell this isn't going to work because 1 minus 2 is negative. And I know my square root part's going to be positive, plus 1. But you can go ahead and find it if you need to. So square root of 4 is 2. 2 plus 1 does not equal 1. Oops. 2 plus 1 does not equal 1 minus 2. So 1's out. and then check 4. So when I check 4, I have the square root of 5 minus 4 plus 1. I want to see if it's equal to 4 minus 2. So I have 1 plus 1 is 2. Yes, that does equal 2. So that one works. Okay, sometimes both of them will not work. So at the end it says always check. Do you guys remember what that's called when you have an extra solution?
Extraneous solution.
Yep, extraneous. So always check, you could have an extraneous solution. So it just means an extra solution that looks like it works when you solve, but when you go back and check, it doesn't work. So it could give you like a negative under the square root, or it could give you an answer that's not matching up with the other side. All right, so that's additional topic number 2. Pretty easy, not too bad. Some of you guys still have trouble with factoring, so if you're having trouble, let me know.